I think this is probably going to be the final part of the sprite tutorials, and I'm just going to kind of wrap up talking about some unique things I've discovered that you can do with sprites. So one is how to attach two or more sprites together. So in other words, how you could use one sprite to carry another sprite around. Um, the next topic I want to talk about is how to make a sprite solid but not solid. And what I mean by that is when you define a sprite's collision width and height, you no longer can move inside of that sprite with another sprite because you've essentially made it solid. But what if you need to be able to move into that sprite, like say in the instance here of fire on top of these crates here? I wouldn't be able to push a crate into the fire here if I simply had defined the sprite's collision width and height and left it at that, because it would then be solid. So I'm going to show you how I was able to make it so that a sprite has a defined collision width and height and still be able to move into into a section where it is. The other thing I want to talk about is some animation. I'll give some examples of how you can do different animations pretty quickly and easily using sprites. And then the last thing is duplication. How you can create a sprite that duplicates over and over again. So I guess the simplest way I can try and put this is, if you want to attach a sprite to another sprite, then you need to put a sprite's XY coordinates in relation to another sprite's XY coordinates using a couple of expressions, and then you need to do that over and over again every cycle, so that the sprite that's attached to the other sprite always will be at that same position. Okay, so for my game here, I have objects that can be carried at two positions, when the player is facing to the left and when the player is facing to the right. So I basically need to define two positions that the sprite will be located at. And I did that like so. So if the player is standing facing right, I use the command put sprite and then the counter that defines the sprite being carried as local puts the sprite at the sprite player x plus 5 spaces. That puts it just past the player's right side. And then I say sprite player y minus sprite local height minus 2. So it takes the sprite local height, subtracts 2 from that, and then subtracts that from the sprite player y. And that's how I arrive at the position that the box is being carried at. So that expression basically works for boxes of all sizes. Basically, I will always have a object being carried one space off the ground using that expression. So it takes the sprite local height, subtracts 2, and then subtracts that from the sprite player y. And then if I'm facing to the left, it goes to this label here, and it puts sprite local at sprite player x minus, or sprite local width minus 2 minus sprite player x. So it takes the sprite local's width, subtracts 2 from that, and then subtracts that from the sprite player x, and that's how the box is able to be just off the player's left side. And then for the y position, I use the same expression that I use above, which is sprite local height minus 2, and then I subtract that from sprite player y. So you'll have to play around and experiment on your own, because obviously you're game is not going to be the same as my game. You may have a top-down game or some other game, but you get the basic idea. This is how you attach two sprites together. You basically need to put one sprite in relation to another sprite and then update that every cycle so that as the master sprite is moving around, the slave sprite stays with it at all times in that same position. Alright, to make a sprite solid but not solid, or to be able to have a collision box for a sprite but still be able to move into that sprite, like in the case of the fire that I've created in my game, you basically need to set the sprite's collision width and collision height and then change it back to 0 every cycle. So when the fire object begins to run in my game, it sets the collision width and the collision height to the given parameters of the size of the fire, and then it checks to see if sprite is colliding. If the fire sprite is colliding with anything, and if it is, it goes to a label, and if it's not, it switches the collision width and the collision height back to 0 within the same cycle before the cycle ends. And so that way the robot that is running the sprite, the fire sprite, is able to check for collision, but no other sprites on board are able to collide with that sprite, because when the robot that has the fire sprite is at rest, the collision width and the collision height for the fire sprite are at 0. So every other robot on board is not able to detect that the fire sprite has any collision width or collision height. So hopefully I explained that well enough to where it makes sense. Basically, if I didn't do that, then what would happen when the robot went into the fire was he would just stand on top of it rather than actually going inside of it, and nothing would happen really. The robot wouldn't die because it would just be standing on top of the fire, and what I need to happen is the robot needs to be able to go inside the fire in order to be killed. So hopefully that makes enough sense to you. If you have questions for me, you can email me and I can answer them. Alright, so as far as animation goes for sprites, if you have a sprite object like this door here that doesn't really change its physical appearance any between animation frames, it's just basically moving up and down like this, you don't have to do a whole lot. Basically all you would have to do is let's see here. So you just basically need to draw your sprite, and then you would just change. In this case, I'm just changing the reference Y of the sprite. So when the door opens, the reference Y point is actually moving down like this until it reaches this point here, and then the door is all the way open. And so basically the sprite is still in the same position, but all of the characters of the sprite are empty, and the player can simply walk through the sprite without any collision because I have collision check set to 2. So, and then when the door closes, the Y position just moves back north, and the door will be closed again. Another really easy way to do animation is the way I'm doing it for this swinging vine here, and that is to just change the X reference point and just have different frames drawn for the vine that move the vine into a different position, and just have it loop back and forth in a continuous loop. So what that looks like on the board is, let's see, where is that? Okay, so it's basically here. So I've defined the sprite's width and height parameters, and then I just create basically animation cells, and inside those animation cells I've just drawn, oh, well, it's I don't have all the characters displayed correctly here. There we go, that was easy enough to fix. So basically I just have these different animation cells here, and all the program is doing is just looping back and forth from one frame of animation to the other, like that, and going back and forth till it gets to the end, and then it goes back to the beginning. Very simple. Alright, so the other really easy types of animation that you can do with sprites is either loading different character sets or loading different MZM files into the place where the sprite is referenced from. I've already gone over how to load partial character sets to create animation in the character set tutorial. So if you haven't checked that one out yet, then you should do that to see about loading character sets. But for MZM files, I'll go over that real quick. So basically this is the place that my fire sprites are referenced from. And so what I've done is I created a series of MZM files that just has basically the fire animation, and it's just basically the flames are sort of moving up and down, and they appear to sort of rise and fall. And what I did was created a robot that just has a loop that loads the fire MZM into 5 consecutive spots along the board, and so they're basically all the fire MZMs are right next to each other. They're about, I think, 8 characters long, so I just repeated them 5 times for a total length of 40 characters. And it just puts a MZM file into the spot, and then what I did was I named the MZM files fire 1 through 6. So I just created 6 animations that basically loop, and I named them 1 through 6, and so they're just loaded with this loop count counter. The loop count counter just loops for a total of 5 times, and then it goes back. When it's done, it goes back to the top and starts again, and that's basically how the loading MZM file animation works for sprites. I'll show you what that looks like real quick. So if I move up to the top of the board here, so that is the fire animation that is looping right now. So any fire sprites on board are just referenced to this point here, and then sections of fire that are smaller, I just use a smaller section of the total area. So for a fire that's across a large crate, I use 8 characters long and 4 characters high, and then on smaller crates I use 6 characters long and 3 characters high, or 4 characters long and 2 characters high. So that's, go back down here. So that's how these are created. Alright, so the last thing I want to talk about is sprite duplication. And this is something that's actually not too easy to do. It can be kind of tricky. At the end of this, I'll talk about a few pitfalls that you have to avoid with sprite duplication. But basically, you need to have a robot that duplicates itself and generates a sprite on the fly every time it does. So I have a bullet sprite here that basically, when it's used, it just generates bullets, and it's a quick little sprite. It's only 94 lines long, so I'll try and go through it real quick and show you how it works. So basically, the robot that generates bullets sits in a position on the board doing nothing. Its routine is ended. When it receives the label go, it first checks that if it's blocked east, and if it does, it goes to pause. It doesn't do anything. But if it's not blocked east, it duplicates itself to east, and then it immediately sends the robot that is to the east of itself to to the label shooting, and then it ends again. So basically, the robot that gets duplicated starts, and the first command here is end, so it does nothing. Ignore the zap commands; they don't pertain to what I'm explaining here. They're part of my game. So basically, the robot gets generated and it ends until it receives the command shooting, and then it goes to this point here and it restores some labels. And these labels are for the purpose of pausing the game. So these labels are zapped so that the robot that's just sitting there doesn't pause itself as well. Anyway, so the first thing that the sprite does is the first thing that the robot does is it has to generate a sprite. And it does that by going through a loop here and looking for whether a sprite's width is greater than 0 or not. And that's how I'm able to tell if a sprite is already using those sprite parameters or not. So it starts at 0, so it checks if sprite 0 width equals 0, and if it does, it goes to the so if a sprite's width is 0, it would go down here to the label next. If a sprite's width is not 0, then there is already a sprite in that position, so it would continue through the loop and it would increase it would increment loop count 1 every time and continue to check for sprite, and it would continue to check through the sprite list until it found a sprite whose width equals 0, and then it would go down here to the label next, and it would set the sprite's parameters. So first it was set local to the value loop count plus 2. It comes down here to next and sets local to the value of loop count plus slow sprite, which is the expression I was using up here to figure out which sprite width equals 0. So local becomes the sprite's number, and then the robot becomes named sprite local or sprite number, whichever number sprite that is. Local 2 becomes the sprite's X position on screen, and local 3 becomes the sprite's Y position on screen, and local 8 becomes the direction of the bullet, either left or right. And then it sets the counters. So collision check, it's set to 2. V layer, because the bullet, the representation of the bullet is actually referenced from the V layer, not the board. So the reference X and the reference Y are 0, 7. That's the location on the V layer where the bullet appears. Though the width and the height are both 1 because this is a 1 block character. And the collision X and the collision X and the collision Y are 0, 0, and the collision width and the collision height, they're both 0, and I'll explain why in a minute. Then it sets the sprite's X and Y position to local 2 and local 3. And then the robot actually moves to a position on the board where it is no longer next to the bullet robot that first generated it, and that is so that the bullet robot can generate another robot, just so the bullet robot can keep generating more bullets, basically. So it goes to XY position 1, and then the robot's ID plus 4. That moves it to a position on the left side of the board that basically won't overwrite anything else on the board that I'm using. So it plays a sound effect, and then it puts the sprite on the board, and then it goes through a loop where it starts actually moving. So the first part of this loop here sets the bullet sprite's width and height to 1 and 1, so that the bullet has a physical representation on the board, and then it checks for sprite collision, see if the bullet is colliding with anything, and if it does, it goes to the label crash. And if it doesn't, it sets the collision width and height back to 0, and it increases the bullet's position on the board, and it goes back to or it ends the loop actually. And I created a limit to where bullets only travel for 20 spaces and then they end. So it loops for 20 and then it goes to crash 2. So down here at crash, the bullet checks to see if it's colliding with the player or another object, and if it's colliding with the player, it sends the player to the message hit, and if it's colliding with any other sprite, it sends that sprite the label shot. And then at the end, basically the robot sets the sprite's width back to 0, and it turns the sprite off and it dies. And it sets the sprite width back to 0 so that that sprite can then be used again by a different robot, such as a bullet later. I always check for sprite width, whether it's set to 0 or not, to know whether I can generate a sprite on the board or not. So if I didn't set sprite width back to 0, I would eventually run out of sprites that I could create. So that's how you create a robot that duplicates itself on the board. And this does it very, very quickly. I'll show you an example real quick of the bullet robot in action. So here's an example. I'm in debug mode right now so I don't die, but this remote control plane is actually shooting the bullets at me, and so that's an example of the bullet duplicating program in action. It's actually shooting bullets at me, and so that's how fast robots can be duplicated. You can duplicate a robot every cycle if you want, and you can generate a sprite every cycle, and it works just that easy. The other thing I wanted to talk about before I finish up all this sprite stuff is I wanted to talk about sprite management in a primarily sprite-based game. So the way I do it with my game is when I start a board, the first thing that happens is all the sprites are initialized, or all the sprites that are used on every board of the game are initialized with this one robot just called load V layer. And so it sets up all the initial counters for the game. I'm going to go down here. And then it starts initializing all the sprites that are used throughout the game. And these are the sprites that are universal sprites, so they appear on every board. So I have a scenery sprite, a background layer sprite, the playing field, which is the ground, and then the sprites that are used only per level. So basically the unique sprites, or the sprites that are unique to each level, I've basically given those sprite numbers 4 through 227. So I've kind of set those aside, and I know that those are only used on a per level basis. And I have those created in the level and then cleared when I leave the level. And then the player is sprite 228. His laser beam is 229. The laser spot that hits the wall is 230. Foreground is 231, and then these are open for use. They're also per level, but I use them for bombs, explosions, timers, and splashes. And then I left 240 and 241 open, so I could use those for something like rain or snow. So I have thrown objects, use 242 and 243, and then basically it's user interface sprites after that. So these are mostly static sprites. So I have the level info pane, dialogue pane, the excuse me, the ability info, save menu, tablet user interface, the tablet halo, the palette tool, the button menu, the message, the border message, effects, the pause menu, and then last I have a character set and a second layer of effects. And so that is pretty much all the sprites are accounted for in the game. So as you can see, you really have quite a few sprites at your disposal. Now if I go and test the game, I can show you how many sprites are on this level. So basically all these sprite numbers are taken up to about, 224. So 213 is so basically 204 through 213 is all level sprites in this test board, and I have a lot of sprites used on the test board. And then, like I said, 224 on up are basically set aside for player and stuff like that. Or actually, I'm sorry, 227 and 228 are all set aside for level and stuff like that. And then if you look around, so basically all the crates, all of the floppies, all of the tablets, and I've got stuff just hidden everywhere throughout this test board. This test board really kind of tests the limits of what this system can do, especially on this small, slow laptop. So these are kind of ice ramps and they're sprites. These are kind of slider crates and they're sprites. There's some more crates. There's some buttons and springs. There's some more crates, and then fire, of course, is also sprites. And there's some RAM cards. So as you can see, I've got sprites everywhere, and the level itself is a sprite. So really, 255 sprites might not seem like enough for your game, but if you utilize it correctly, it really is enough. Alright, so this is basically my sprite table here, or actually it's more like my robot table, and I've got kind of representations of what sprites are created with these robots here. And if I show you what one of these looks like, basically when you start the game, the board-specific sprites are created by these robots. So the first thing it does is, after some initialization that you don't need to kind of worry yourself about, it sets the local counter. Actually, okay, here's something else I should explain. Back to the other robot for a minute. Okay, so the first 4 sprites basically are set aside and used for gameplay. So sprite 0 is the scenery, and then I've got 2 parallax layers, and then I've got the playing field. So sprites 0 through 3 are taken. So I set a counter called low sprite, and I set it to 4, and I use that when I initialize the board sprites so that no sprite on the board overwrites any of those first 3 playing field sprites. So here's how that works. I set local to robot ID. So whatever the robot's ID number is, that's what it sets the sprite number to, or that's what it sets the local counter to. And then I use an if condition here. So if local is less than or equal to low sprite, or I'm sorry, if local is greater than or equal to low sprite, the counter low sprite, which equals 4, go to next, which is down here. But if local is less than low sprite, then that means that the robot's ID number is either 0, 1, 2, or 3. So it will set local to player, which is 227 minus low sprite, so it subtracts 4 from that, and then it adds that to the robot ID. So basically it moves the first four robots, like robot 0, 1, 2, and 3, it moves their sprite numbers up to 220, 224, 223, 224, 225, and 226. So that makes sure that I don't overwrite any of those first 3 sprites that I've already created. So then it comes down here to the next label, and it sets a string that I named Scorpion so that I can identify this robot. and then I set the XY position that this robot is on board, and then it goes on to initialize the sprite by setting the counters appropriately. So I'm referencing the location of the scorpion sprite animation, and I'm setting the width and the height of the scorpion, and then it places the scorpion on board and it begins operating the program. So that is how the board specific sprites are initialized. And then once I am done with the board and I exit, there is a robot here called General that I send it the message clear when I'm leaving the board, and every board specific robot stops running at that point, and I clear a few counters, and I clear all the counters that the board specific sprites are using. So I sprite, basically it takes loop count and adds 4 to it, so it starts with the 4th sprite, and it zeroes out all of the counters that the sprite would initialize. So anything, I took everything into account, basically V-layer, collision check, reference X, reference Y, width and height, collision, static, and then it sets off to 1, so that actually turns the board sprite off. And some sprites can actually be set on fire, so I have a counter that monitors that, so I set that back to 0. And then if I identified the sprite with a string, if I identified this sprite with a string by creating a string name, then I clear that as well, so that everything can be used fresh again on the next board that I create. And then this here clears the sprites that are after the player and the player's laser beam and stuff. Those are the sprites that are used for bombs and explosions and timers and splashes and stuff. So those are cleared as well. And then it ends. So then the board can be left, and basically at that point the only sprites that are still active are the game sprites, the user interface, the player, the level, and all of that stuff can be reused fresh the next time I enter a level. So basically that's what happens every time. This robot exists on every board, the load V layer sprite, but it only gets used once at the loading of the game. So after the game has been loaded once, it does not go and reload all of this information again. All of these counters that are set initially and all of these sprites that are initialized initially will stay that way for the course of the game, and then the board specific sprites will be initialized at the beginning of every level. So basically every time you enter the level, all of the sprites are reinitialized fresh, and everything starts at the beginning of the level as if it was the first time you had entered it. And I do that by using a swap world command, and I swap to the same game. I can show you that real quick too. It's in the general sprite here. So it's been a little while since I've looked at this, so I may have to remember how I did it. So basically, if local already equals 1, then I go to the then I go into the label swap out. And down here, when I go to swap out, it stops the main player engine from running for a second, sets local to 0, and says swap world servo MZX. So that's this game. So it basically does a swap world to the same game. And the first board that the game goes to when it starts is called the swap board, which is right here. And it just basically let me find the there. So there's a robot on the swap board that basically there's a transition when it enters, and the swap board decides what board to go to. So at every board, I set a string that is the board name, and so when I come here, the swap board robot just teleports the player back to the robot that it was previously on by using that string that was set when I was in the last level. So then so from the swap board, I would come back to this level here, and everything would be initialized fresh again. So this would be basically all of the counters carry over from the previous world that I swapped from. So basically no counters have to be reinitialized, but all of the robots start fresh again, so they all start in their default position. So I have all of these robots here that are already in these positions, and they start fresh, so they kind of regenerate all the counters that they had set previously by setting them again. So this tablet robot would set the tablet counters, and then it would load the tablet robot program and begin running that tablet program. And so basically that would basically start loading a tablet robot. So it would initialize the sprite again, and then it would begin its program again. That's how that works. So the other thing I should mention is, so all of these robots, once they've initialized the sprites, they don't need to be on the board anymore. They actually need to move off the board so that you can't see them. So I have them go to the left side of the board, and basically they go to the position 0 and then whatever their robot ID is. So that lines them up along the left edge of the board. So if I had and so they will start somewhere along here, and they'll just line themselves up vertically. So if I had robot 10, it would appear here, and then the robot ID number 15 would go here, and so on and so forth. I'll actually show you what that looks like real quick, just for fun. You can't normally see all the way to the edge of the board, but if I go into debug mode, I can. So this is actually all of the sprite robots are all along here now. So all of these robots are used on the board. There's even a few down here. I don't believe there's any. Oh, okay, there is some down here. So, and you can look at the bottom of the screen to see my my X and Y positions. So this is 184 I'm at right now, Y. So this robot is robot ID number 185. So we can continue on down here, and that is where it ends. Basically, there's no robots below that point. So these are all board robots that have lined themselves up over here. So the last thing I wanted to talk about in this final sprite tutorial was I was going to mention some of the pitfalls of duplication of sprites, that sort of thing. So the way I designed this game, everything works fine. Everything worked fine originally until I started having sprites that duplicated themselves repeatedly. And then I started having bugs, like robots would disappear and sprite programs would stop working. And I found out that this was because when using a swap world command, or when saving, even just using the saving command, robots would actually reorder themselves, and they would actually be generated, or they would actually get a different sprite number. So that caused a problem, because I could have a robot over here in a position that was no longer its position. So it could be robot 19 until I used a save command, and then all the robot IDs reordered, and this could be robot 23, and then a new robot could be generated that was robot ID 19, and when it created a sprite and it went to the when it went to the go-to position of 0, 19, because that's its robot ID number, it would overwrite an existing robot and would begin a program, but it would erase another robot. So I've got a few robots that create sprites that duplicate themselves. Basically enemy bullets, bombs, timers, crates that are actually just fire that appears on top of crates when fire is created, and then cannonballs and the splashes that you see when something hits water. Those are all basically handled by robots that can duplicate the sprite over and over and over again on the fly. So what I found was that I couldn't have the standard method of creating a sprite on board that I was using when the board first begins, which is this method that I already showed you earlier. So I had to come up with a new method, and so what I did was I'll show you real quick with the let me find the splash sprite. I don't know if that's the best one or not. So when a splash is generated, so the first thing that happens is the robot duplicates itself, and after it duplicates itself, it restores a zapped label called reorder, and then it generates the sprite, and it does that by starting at the top of the sprite list and going down. And I did that because I want splashes to appear over as many other sprites as possible. So I start at the top of the open sprite list, which is sprite 239, and I start looking for a sprite whose width equals 0, and I continue to look all the way down to like sprite 4. And if I don't find an open sprite, then I get the message that there's too many sprites. So then I've got a bug. So I got to make sure that I don't have too many sprites on board. So after the local counter is chosen, it creates the sprite. And then whenever I use the swap world command, or whenever I save my game, I send all robots the message reorder, and that has them move on board momentarily so that they don't overwrite each other. And I should back up in for 1 second and point out something else. I don't have these robots that duplicate themselves move to the same position on the board that that all the rest of the robots go to. So normally when a robot when the board first opens, all the robots that are initialized, the initial sprites, they go to position 0 and then robot ID. And what I had the robots that duplicate themselves do is I have them go to position 1 and then robot ID +4. And that's so that they don't overwrite any of the board robots. So those board robots, basically that far left column is protected, so it never has new robots coming into that space. So all of the duplicate robots come over here, and they start down here below this ladder image so that I don't overwrite that. So robots generate from here on down when they are robots that duplicate themselves. And so when they all get the message to reorder, they momentarily go to position robot ID +2 31. So that takes them out of their left column staging, and that puts them right here. So they move to this spot on the board momentarily. So they'll go somewhere along here based on their robot ID, and then they'll immediately jump back over here to the left column. And that's so that they can reorder themselves, because their robot ID number may have changed. So to keep new robots who are coming in from deleting pre-existing robots whose ID has changed, I have them just all reorder themselves by going to the column format and then back to the row format immediately, and then returning to their normal programming. So this is just a subroutine that it gets called. They jump out of their program they're running momentarily and they go to a new position on the board, and then they go back into their program. So that's how the reordering works, and that was what saved me from having basically programs disappearing and sprites stop working whenever I was saving or using the swap world function. And that's it.